introduce one of the most important concepts in normal distribution, which is referred to as a standard normal distribution. A standard normal random variable. I know that a random variable x is said to follow a normal distribution with parameter mu and sigma, where sigma is my standard deviation and mu is my mean. Some books refer to as normal with mean mu and sigma square. Sigma square would be the variance and mean, this is going to be the mean or the expected value. I define a standard normal variable if the mu is equal to 0 and standard deviation equal to 1. So, normal random variable with having an expected value 0 and standard deviation equal to 1 is referred to as a standard normal random variable. And the density curve is going to be called the standard normal curve. We have already seen that there is going to be a bell shape. The only thing we need to notice here is the mean, which is equal to 0. This is going to be my mean, mean is equal to 0, sigma equal to 1. So, my mu plus sigma equal to 1, mu minus sigma equal to minus 1. So, I have this is my mu plus minus sigma, mu plus sigma. This is going to be mu plus 2 sigma, this would be my mu minus 2 sigma, this is going to be mu plus 3 sigma, and this is going to be mu minus 3 sigma. So, this is represented, a standard normal variable is typically represented by the alphabet Z, and this is having mean equal to 0 and standard deviation equal to 1. So, the approximate rule for the standard normal is the same. So, since mu minus sigma and mu plus sigma in the standard normal case is the interval between minus 1 and 1, I have 68% of a standard normal observations which lie between minus 1 and 1. Mu minus 2 sigma to mu plus 2 sigma is going to be minus 2 to 2. I will have 95% which would lie between minus 2 and 2, and 99.7% which would lie between mu minus 3 sigma and mu plus 3 sigma, which is minus 3 and 3. So, the approximation rule for the standard normal is also the same as I understand and recognize what are mu minus sigma, mu minus 2 sigma and mu minus 3 sigma, so forth in the standard normal. So, given the standard normal, we can just apply the approximate standard normal to find out what are the standard normal probabilities. For example, the probability Z lies between minus 2 and 2 is the same as the chance that the random variable lies within mu plus 2 sigma and mu minus 2 sigma. I already know 95% lies between minus 2 and 2. So, this answer is a straightforward 0.95. To find out what is the probability Z is greater than minus 1, I know that probability Z is greater than 0 is going to be 0.5. The probability minus 1 to 0 again I know is a 0.34. So, the probability Z is greater than minus 1 is going to be 0.84. Another way to look at it is we know that this probability is 0.16. We have already computed that. So, 1 minus 0.16 is 0.84. So, this probability Z is greater than minus 1 is 0.84. For Z greater than 1, I can do the same thing. This is going to be 0.5. So, and this is going to be 0.34. So, this probability is 0.84, which gives me this probability is 0.16. 1 minus that is 0.16. Z greater than 3, I know this area is equal to 0, so it is straightforward. Z less than 2 is 2 ways to find that out. Again, this I know is 0.34, this I know is 0.135. So, 0.34 plus 0.135 plus 0.5 would give me this value of point Z is less than 2, which is the same as 0.975. I can find that out as this probability of the orange region here is 0.025. So, 1 minus 0.025 is 0.975, which gives me the probability of z less than 2 is 0.975. There are a few properties that come in handy for us to understand. One of them is probability z is less than or equal to minus x. So, I know that if I have a 0 here, the mirror image, any value here and here are going to be mirror images of each other. So, if I have a x here, I am going to have a minus x here because the mean is around 0. So, the probability, again using the symmetric nature, this shaded region is going to be that will give me probability of z is less than minus x, and this shaded region is going to give me probability z is greater than x. I know that both of them are same. But probability z is greater than x is same as 1 minus probability z is less than or equal to x. Hence, probability z is less than x is the same as 1 minus probability z is less than x. This is one important identity. The second identity is to find out given a and b. So, here again you can see that a is going to be less than mu, which is equal to 0. Given any a and b, I can write the probability a is less than or equal z is less than b is probability z is less than b minus probability z is less than a. Now, how do we establish this? Probability a, this shaded region gives me probability of a is less than z is less than b. Now, I can express this blue shaded region as the following. The orange shaded region minus the green shaded region is going to give me the blue shaded region. The orange shaded region is nothing but probability z is less than b. The green shaded region is the probability z is less than a. The difference in these two shaded regions is going to give me a is less than z is less than b, which is precisely this identity. So, this given any a and b, I can express the probability a is less than z is less than b as probability z is less than b minus probability z is less than a. The third property is to find out what is probability z modulus of z is greater than a. Modulus of z is greater than a is the same as z is greater than a or minus z is greater than a. So, the probability of z is greater than a is probability z is greater than a or minus z is greater than a. I know that probability of these two is the addition of this probability. Now, probability z is greater than a is given by this shaded region, minus z is greater than a is same as z is less than minus a, which is given by this shaded region. So, I know that probability mod z is greater than a is same as probability z is greater than a plus probability z is less than minus a. Again, these two are same. So, I can write this as 2 times probability z is greater than a. I know probability z is greater than a is same as 1 minus probability z is less than a, which establishes this identity. In other words, so probability mod z is greater than a is 2 times probability 1 minus probability z is less than a. Similarly, what is probability mod z is less than a? I know mod z is less than a is going to be probability z is less than a plus minus z is less than a. So, this would be probability z is less than a and z is greater than minus a. So, this is the area. So, if I am going to have the area, it is going to be the yellow area is going to be the area which is going to be probability of mod. So, the yellow area is going to give me probability of mod z is less than a, that is this area is going to give me probability of mod z is less than a. So, the probability of mod z is less than a is the same as probability z is less than a, and so I can rewrite this as probability of minus a is less than z is less than a. Again I know that this is the same as probability of, so I have this as probability z less than a, this area minus probability z is less than minus a, that is the orange. The yellow probability is going to be this entire probability minus this probability, which I can further write it as probability z is less than minus a is same as probability z is greater than a. Okay. And I know that this is nothing but 2 times probability z is less than a minus 1. Okay. So, we have got two important identities, one is probability mod z is greater than a, which is the blue area, and probability of mod z is less than a, which is the yellow area. Thing is what we refer to as a standard normal table. What is a standard normal table? So, in the earlier days with less computing power, we had to tabulate these probabilities, and the normal probabilities were tabulated in an efficient way. One of such tables were referred to as a standard normal tables. Now, for all purposes of your beginners course, every student should know how to read the standard normal table, irrespective of whether they are going to use in their future the tables to compute the probabilities. But for a foundation course, we strongly recommend that every learner should know how to read a standard normal table. So, what are the elements of a standard normal table? So, given a normal probability curve, the standard normal table gives us on the column it gives z, and on the rows it gives, for example, this value is probability z is less than or equal to 0, which is very evident again in a standard normal distribution. I know this is 0, this probability is going to be 0.5. So, this value is probability z is less than or equal to 0. So, this probability is 0.1 is 0.5398, 0.2 is 0.5793, 0.11 is 0.5438, 0.12, so z is less than 0.12 is 0.5478, 0.84 is 0.7995, 1.25 is 0.8944. So forth you can find out the entire standard normal table, where the way we read it is the probability of, so this table gives me probability of z is less than or equal to z, where this z is 0.1 into, so the first thing, if I want 1.1, it would be 1.1 into this first column, 1.11 would be 1.1 into this column, 1.42 be 1.4 into this column. So, that is how I can compute the probabilities. The standard normal table is extremely important and helpful in computing the probabilities. So, let us do a few probabilities. Probability z is less than 2.2. Let us go here. I have a 2.2 here. So, I can see that the probability of z is less than 2.2 is this probability 0.9871. Similarly, probability z is greater than 1.1. I know this table gives me probability z is less than 1.1. I also know that probability of z greater than 1.1 is equal to 1 minus probability of z is less than 1.1. Now, probability z is less than 1.1 is what I have from my tables is 0.8643. So, probability z is less than 1.1 from my table is 0.8643, which gives me probability of z greater than 1.1 is 1 minus 0.8643, which is equal to 0.1357. 0 is less than z is less than 2. Again, what the table gives me is the probability of z is less than or equal to 2. I want this probability. Now, what this probability is going to be is 0 is less than z is less than 2 is going to be this probability which I give as a, and this I know is 0.5. So, a minus 0.5 would give me the probability 0 is less than z is less than 2. So, what is probability z is less than 2? Again, I go back to my tables. For z is less than 2, I go back to my table for z is less than 2. You can see that it is 0.9772. So, the probability z is less than or equal to 2 is 0.9772. Probability z is less than or equal to 0 is 0.5, which gives me probability 0 is less than z is less than or equal to 2 is the difference of these two, which is 0.4772. Okay, it is 0.4772. So, the next probability we are going to see is what is the probability of, so again I know z is 0, okay, and I want to know 0.9 minus 0.9 to 1.2. So, the first thing I will find out is what is probability z is less than 1.2, that would give me this shaded region. The green shaded region is going to give me the probability z is less than 0.9. The green shaded region would give me z is less than 0.9, okay, and the yellow is going to give me probability the entire yellow. So, this only this yellow will tell me the probability I need. So, the yellow probability is what I am going to get as, so probability, the yellow probability is what I am going to get. I can write this probability as probability z is less than 1.2 minus probability z is less than 0.9. This is the green shaded region. This would be the entire shaded region here. Now, z is less than 1.2 I can get from my normal probability tables. For z is less than 0.9, I recognize that probably z is less than 0.9 is same as z is greater than 0.9. Okay. Now, to get z is greater than 0.9, I have z is greater than 0.9 is 1 minus probability z is less than 0.9. So, to find out this probability, it is same as probability z is less than 1.2 minus 1 plus probability z is less than 0.9. So, that is this probability which I have. What is probability z is less than 1.2? Z is less than 1.2 is going to be 0.8849. Probability z is, so I know that this is going to be probability z is less than 1.2 plus probability z is less than 0.9 minus 1. We have just established that. Z is less than 0.9 is 0.8159. minus 1. So, I get an 8, 0, 0, 1.7008 minus 1, which is a 0.7008. That is the answer I have here. Okay. So, the next problem is, what is probability z is greater than minus 1.96? Again, let us go back to this curve. I know this is a 0, this would be my minus 1.196, this is going to be my 1.96, again due to symmetry. I want this probability. I know that this probability is going to be the same as this probability. The probability x is greater than or equal to this is the same as probability z is less than 1.96. Hence, I can find out that 1.9 and 6, it is 0.975. Hence, the probability z is greater than minus 1.96. I recognize the same as probability 1, z is less than 1.96. Z is less than 1.96 is 0.975. So, that is probability z is greater than minus 1.96 is 0.975. For probability z is less than minus 0.72, again this is my 0, this is my 0.72, again by my this one I am interested in this area, I know that area is same as this area. So, probability z is less than minus 0.72 is going to be same as probability z is greater than 0.72. Z is greater than 0.72 is 1 minus probability z is less than 0.72. I know what is 0.72 is 0.7642. 1 minus 0.7642 is going to be 0.2358, and that is the answer we have here. Again, let us look at the normal probabilities of mod z is less than 1.64. Again, recall, I know probability mod z is less than a. We have just computed probability mod z is less than a is 2 times probability z is less than a minus 1. So, again to compute this probability 1.64, I go back to my normal tables. 1.64 is 0.9495, 2 into 0.9495 is going to be, so I know probability mod z is less than a is 2 times z is less than a minus 1. Probability z is less than 1.64 is 0.9495. 2 times this is going to be 1919, which is going to be 1.899 minus 1 is a 0.899, which is the answer I have here. So, for probability mod z is greater than a, I know this is 2 into 1 minus probability z is less than a. This is something which you have just established. So, 2 into probability z is less than 1.2 is 0.8849. So, 1 minus, so 2 into 1 minus 0.8849 is going to be equal to 2 into 2302. Now, the last one, probability of minus 2.2 is less than z is less than 1.2. Again, how do we use the approximate rule? Again, I have, how do I use the standard normal table? I need to find minus 2.2 and 1.2. Again, you see that this is not symmetric, but I know that this probability minus 2.2 is less than z is less than 1.2 is same as probability z is less than 1.2. This area minus this area, which is probability z is less than minus 2.2. Probability z is less than minus 2.2 is same as probability z is greater than 2.2, which is same as 1 minus probability z is less than 2.2. So, I have in effect I have probability minus 2.2 is less than z is less than 1.2 is same as probability z is less than 1.2 minus 1 plus probability z is less than 2.2. Probability z is less than 1.2 is 0.8849. Probability z is less than 0.979861 minus 1, which would give me a probability of 0.8710. So, now how do I use the normal tables to compute an unknown x? So, many a time we are given a probability and I need to know an x. For example, probability 3 is less than z is less than minus 1 is equal to 1 is less than z is less than 3. I know that these areas for are same when x equal to 3. I can just compute that x equal to 3. So, now let us look at the given the value or the probability, what is the value of x. So, from the probability tables I know the probability. So, I know that probability x is greater than x is 0.05. Z is greater than x is 0.05. What is the value of x? Probability z is greater than x is 0.5 is same as probability z is less than x is 0.95. I go to my table, I see that 0.95 is appearing with a 1.65. So, I know probability z is less than 1.65 is 0.95. Hence, my x is 1.65. Similarly, if probability z is greater than x is 0.005, probability z is less than x is going to be 0.975. Now, I can see that probability z is greater than x equal to 0.975 comes at this point 0.99 995, which is at 2.58, hence x equal to 2.58. Now, the third one, probability z is less than x is equal to 0.75. Again, I know that we have already seen probability of mod z is less than x is same as 2 times probability z is less than x minus 1. We have been given that this is equal to 0.75, which will give me 2 times probability z is less than x is equal to 1.75, which will further give me probability z is less than x is going to be 0.875. Now, if I look at 0.875, I can see that that appears at 1.15, solving x equal to 1.15. So, given the probabilities, I can find out what is the x. So, in this section, we have found out or we have discussed what is the standard normal distribution and how to use the normal tables to compute probabilities, and given the probabilities, how do we inversely find out what is this x.